Hello everyone. I will be doing question 12 from page 553. This is for unit 14. Okay, so the question is, an airplane passes directly over a radar station at time t is equal to 0. The plane maintains an altitude of 4 kilometers and is flying at a speed of 560 kilometers per hour. Let d represent the distance from the radar station to the plane, so which is this, and let S represent the horizontal distance traveled by the plane since it passed over the radar station. So this. Okay, so for part A, it's express D as a function of S and S as a function of T. So in order to express D as a function of S and S as a function of T, I need to solve for S. So I'm given the speed in my question, which is 560 kilometers per hour. Okay, so I'm solving for S, which is this distance, horizontal distance, traveled by the plane since passed over the radar station. So I know that, so I'm given the speed, and I know that distance is speed multiplied by the time. I plug in my value for the speed, and then I solve for the distance. So where time is, I've used t in hours because time is since the time is in hours because it's 560 kilometers per hour. So yeah, and then the hours cancel out, and we get we get the distance is equal to 560 t. So therefore, the function so it says express s as a function of t. So the speed times the time. So we get speed times the time. So s of t is equal to 560 t. Okay. And we also have to express d as a function of s. So now I wanna get an equation for d. So I use the Pythagorean theorem to find an expression for d of s. Since we're asked to express d as a function of s, and this is a triangle, so it's a triangle. So I know I can use Pythagorean theorem to solve for this the equation for this side, for this length. So for d, so so what I did was I did 4 squared because we're given 4 kilometers. So 4 squared plus s squared is equal to d squared. Okay, so since we're solving for we're finding an expression for d. So yeah, I did 16 plus 560 t squared. So I plugged in 560 because we've got the horizontal distance here. So this was which we found. So s of t is equal to 560 t. This gave us the distance, the horizontal distance, which is of s. But I don't. But then, although I plugged it in here, I I I went back to s squared because I expressed it just as s squared because we're not solving for d. We're not finding a value for d. We're just finding an expression, right? So if we were solving for finding the exact value of d, like a number, a specific number, then we would subs we would substitute that. Anyways, so yeah, so when you do that, so I simplified it and I got square root of 16 plus s squared is equal to d. Okay, so now we have our expression for uh, d of s. So since we're asked to express d as a function of s, so there you go. There's that function. Okay, so for part B, it says use composition to express the distance between the plane and the radar station as a function of time. Okay, so they're asking use composition to express the distance between the plane and the radar station as a function of time. So that means this distance. Okay, so that's so d of s, which represents the distance between the plane and the radar station, and we've got that over here. So we've got that expression, right, which we found for part A, since we were asked to express d as a function of s. So yeah, now that we have that expression, we can now plug in 560t for s, which was the value that we found here for this equation. And I mean in this in this function. And so since we so 560t represents s, so it's this horizontal distance. So I plugged that into s, and I got the square root of 16 plus 313,600t. So therefore, ds of t is the distance in kilometers between the plane and the radar station, and t represents the time in hours because we were given time in hours in our question. If because it was because we were given the speed of 560 kilometers per hour, so that means that time is expressed in hours. Okay, so yeah, I hope that this helped, and good luck on your test.